Hi, in this video we will see the glimpse about IoT and how to interface Arduino Uno with ESP8266. Internet of Things is all about plotting the things data, that is, plotting the sensor values to the cloud and controlling the devices from the cloud. For example, we can plot the temperature, humidity, light, pressure, acceleration and much more sensor values to the cloud, and then we can analyze the data for our future use. Now we will see how to do using our Arduino Uno and ESP8266 along with circuit connection. Here we are using ThingsSpeak cloud services for plotting the data. Three components we are going to use for this IoT experiment. First component is Arduino Uno, second component is ESP826601 version, and finally we can use many sensor. For this purpose we are using temperature sensor LM35 along with jumper wires. Now we will see about the cloud where we are going to plot our values. ThingsSpeak is an IoT analytics platform service that allows you to aggregate, visualize, and analyze live data streams in the cloud. You can send data to ThingsSpeak from your devices, create instant visualization of live data, and send alerts. We can use free channels in ThingsSpeak for this demo purpose, so you can also create the account if you wish. So up to now we have seen the components required for this experiment and cloud where we are going to plot the sensor values. Now we will see what type of circuit connection we need to do the experiment. We have two parts in interfacing. One is configuration part and another one is plotting part. First we will see configuration part. First, upload empty sketch, that is empty program, into your Arduino board. While uploading empty code, don't connect ESP8266 serial pins to Arduino Uno board, since both Uno and ESP8266 programming will be done through serial communication. Then we have to connect the TX to TX, RX to RX of Uno with ESP8266, and also regarding power, keep in mind ESP8266 is 3.3 volt. After that, connect the pins according to the circuit diagram and make sure you made correct connection by checking more than twice. After that, open your serial monitor and check whether any messages getting printed on serial monitor at the baud rate of 9600 or 115200, and make sure you have the setting in serial monitor as both NL and CR. We are using AT commands to configure ESP8266. First command we have to give AT and then ESP will reply OK, and then we can just give AT plus RST and it will give the firmware version and some other informations too. And then we have to set whether we are going to make whether our ESP in access point mode or station. We are going to give command AT plus CW mode equals 3 so we can access in both mode. After that we have to check what Wi-Fi networks available, so we are giving AT plus CWLAP, where LAP means list access points. After typing that one it will show all the access point available in the range. And finally we have to give Wi-Fi name and password by giving AT plus CW JAP, where JAP represents join access point. After giving, if it shows Wi-Fi got connected, then we can move forward, and it throws error, check the connection and repeat the steps. After completing the steps we are entering the plotting part, and make sure you have a cloud account with ThingsSpeak for this experiment, but you can use it in any cloud with little modification in the code. Now we will see ThingsSpeak channel creation and API keys to be used. For plotting part, connections will remain the same, but we have to interchange the TX and RX respectively for Uno and ESP. Now we will see the coding part. In coding, we have to set the baud rate based on the ESP we have to change on our code. We have to copy the API keys from ThingsSpeak based on the channel we have created, and in loop part we have to add the code for reading a sensor value, and then since website always accept in the string format whatever the values we are reading, we have to convert it into string, and detailed code explanation will be uploaded as a separate video and blog. So now we are able to plot the temperature sensor to the cloud with ease. For code, click the link, and if you have feeling difficulty in applying, add comment, and thanks for subscribing the channel.